Good afternoon, students. Hope till now you have been watching my videos in the channel Science Geek. So, did you like it so far? I had given some good lessons, and for me, science is everywhere. Science is not in the books, science is beyond the books. So now many new students must have also come to see this video, and the old ones are also there. So today I would like to highlight a very important lesson of chemistry, and that is one of my most favorite lesson. And the name of the lesson, as you have seen, I have kept some flowers in front of you, of the white flowers and the red flowers. I kept something in front of you. It will denote something, it will show you something what I have kept in front of you, right? And it will tell you the significance of why I am showing a bouquet and starting the class. Because life is also like a flower. You have to be well placed in your life, and then only people will look at you, right? So why now the role of these flowers I will tell you after 5 minutes. Before that, you must have seen what is there in the blackboard. What do we see here? The name of the lesson which we will do today is one of a very important lesson for ICSE, CBSE, State Board, everywhere. And this lesson is the modern periodic table, or I give the name, we will do the trends in the modern periodic table. Now, the word periodic table, what does this name tell you? Periodic table, periodic table, periodic table, like a table. Normal table, we keep things, we keep our normal books, our items, household items and all. But what does a periodic table keep? Why the need of a periodic table came? Because of the so many elements which were there in chemistry, which we could not study in an organized way. And in order to study their properties in a systemic, organized way with precision, their physical properties, their chemical properties, the scientists gave rise to this periodic table. So this periodic table did not come in one day. It started with the evolution, like man has evolved, Homo sapiens, right? Like that, the table has also evolved. How has it evolved? Who were the pioneer scientists who played their role in the evolution of periodic table? First was Dobberman. He was the first scientist who had given his initiative. What he did, he thought that the elements with similar properties to place them in a group. He formed a triad of like lithium, sodium, potassium, for example, a triad. And then he found the atomic mass. He placed them as per their increasing atomic mass. And the average of the middle one is nothing, and he found out that the average of the middle one is the mean of the atomic mass of the middle one is the average of the first two. That's what he had found. But this could not be possible with all the elements. Only with some elements it came. So it was not a great success. Then the next person who came in this line was Newland. What he did, he arranged the first 8 elements as per the notes of music. Sa, re, ga, ma, pa, dha, ni, sa. And every 8th element had the properties like that of the first element. So the gradation of properties. But this also had certain limitations. It could not go further. Then came Mendeleev. We have to focus on the modern periodic table. I am telling you the evolution. Dobberman, Newland. Then came Mendeleev. He has given a significant contribution. Like he arranged the elements in increasing order of their atomic mass. The key word I am telling here was atomic mass. For him, 63 elements was there at that time. So he had grouped the elements as per this order, but the limitations were there because he could not place the isotopes, the position of hydrogen was not clear, and he had left certain gaps in the periodic table for the elements to be predicted, which to be discovered, which were later on discovered. And he had named those elements with some gaps. And the later on the elements were discovered, Ika boron, Ika silicon, Ika aluminum. Okay. That is Mendeleev, but limitations were there because position of isotopes, position of hydrogen was not clear. From here came a turning point in the course of periodic table. Now, who was that pioneer scientist who gave his contribution here? And he is known as the father of the modern periodic table, Henry Moseley. He is the basic founder of the periodic table. Now, what does this periodic table states? It states that the table states that the physical and chemical properties of the elements are the periodic function of their atomic number. The key word here is atomic number. It is not atomic mass, it is atomic number. This was the change which he made for the evolution of the modern periodic table, and it was a great success. And you will study this modern periodic table which you have seen here, which I have put here, and it is there in your ICSE book also, very nicely depicted. So you have to keep your book in front of you. As I always tell, book is your Bible, and this is just the last minute revision and quickly in your terms what I want to tell you. You know the lesson, I am just revising the lesson for you. So this is the definition of the modern periodic table. The keyword here is atomic number. Now, another word which you have to keep in your mind is the two things which I have drawn here, I have written here, like you have seen your class timetable. You have first period, second period, third period, fourth period. How you draw a class timetable? When you draw a class timetable, see, you will draw the lines like this to copy the timetable. You will draw the horizontal rows, you will draw the vertical groups. So the horizontal rows here, I can tell you this flower which I have kept here, this white one, the horizontal rows is the white flower, is nothing but the period. So we will study it in terms of the flower also and what I have drawn here also. This white one is the period, remember, the white flowers are the period, and the groups are the columns. Groups are the vertical columns, the columns like we make, right? And they are the termed as the word group. So these are the another two keywords, period and group. There were 7 periods discovered in the modern periodic table, which I will show you. It's there in your book here also. And there are 18 groups in the modern periodic table. And you have to see the periodicity of properties. The periodicity of properties. Now, what does this word periodicity mean? If you want to know the exact definition of periodicity, you should write that the modern periodic table is an arrangement of elements in increasing order of their atomic numbers, and on this criteria the modern periodic table is based. And periodicity of properties means occurrence of characteristic properties of the elements at definite intervals of time in the modern periodic table. Now, when the elements are arranged in their increasing order of their atomic numbers and the properties are repeated at distinct time, recurrence, the keyword is recurrence of the properties at definite interval of time. Okay, now the properties which appear at regular intervals of time in the periodic table are the periodic properties. Now, what are the periodic properties which you have to study? It will be the atomic radius, it will be the ionization potential, it will be electron affinity, it will be electronegativity, it will be the metallic character and the non-metallic character. So this is the background which I had made to make you understand. Evolution of the periodic table, Mosley, what was the term, how we defined it, what is periodicity, what is a period, the horizontal rows are the period, the vertical columns are the group, and periodicity in terms of what? All these properties. Okay, now we will proceed further. Okay, first I told you periodicity. First criteria is atomic radius. Now, everybody knows, we have 9th standard knowledge, nucleus. The nucleus contains the neutrons and the protons, and the total number of protons and the neutrons make the atomic number. Okay, and also you know your previous knowledge tells you, say for example, I take one element, sodium. Always the way we denote the atomic number and the mass number, it's written, the atomic number is written here, this is the atomic number, and we write the mass number here. This is the rule of every element. Every element is written in this way. Sodium, atomic number is written down, subscript, and this is the super subscript, that is the mass number, atomic mass. Now I am talking about atomic radius, periodicity in atomic radius. So what is atomic radius? This is the central part is the nucleus. Nucleus has the neutron and proton, and the distance of this, the distance of the different shells. The different shells, like the shells you know are K, L, M, right? Your previous knowledge. Atomic number 11 can be distributed as 2. Each shell has its own capacity to keep the number of electrons. Bohr's theory, if you know, the 2n square. 2, 8, 1. Here we are distributing it in this way because we have studied this electronic configuration. 2, 8, 1. So this K shell will contain the number of electrons are 2, like that. This is K. I am just telling you atomic radii here. This will be 8 here, 8 here, and the last one will be 1 here, if you take. Now this atomic radii is calculated from the central part of the nucleus to the first shell, second shell, third shell. This is atomic radius, and this gives the atomic size. This whole thing gives the atomic size. It gives the atomic size. Now, and this is also known as the bond length. This is also known as the bond length. Now, this atomic radius is the distance between the center of the nucleus and the outermost shell of the atom. Okay, and it is given in terms of angstrom and picometer. Angstrom and picometer. Unit of atomic radii is angstrom and picometer. Okay, and the atomic radius determines the length of the atom. The length, it determines the bond length. Okay, and this you will see how it is going in a period and in a group. First, the criteria. So this was atomic radius, understood atomic radius. Next one is, next criteria which you will study is ionization potential. Next one is ionization potential. Now what is ionization potential? Potential, see the word ionization potential. If you can see, ionization potential. Potential is the hidden thing, like your potential energy getting converted into kinetic energy when you work, when you study, when you get good result. That is the potential energy getting converted into kinetic energy in terms of physics. Ionization comes from the word ion. So the amount of energy which is required to form an ion. So what is the proper definition, how you can define ionization energy? The amount of energy required to remove an electron from the outermost shell of an isolated gaseous atom. For example, the atom, say for example, I take an element, anything I take as x5. This is the number of electronic configuration is 5, atomic number 5. So how much energy will be required to make it convert into a ion? Ion, say it's giving away. So one electron it is giving away. So it is releasing. So it has to, you have to pull it. So the amount of energy required to remove an electron from the outermost shell of an isolated gaseous atom. This is known as a ionization potential, and always remember here a cation will be formed. A cation will be formed. Okay, a cation will be formed. And this ionization potential is very well related to another word which is the next criteria known as electron affinity. It is the third criteria. Second was this, first was atomic radii. Now electron affinity and ionization potential are closely related. The definition of affinity means attraction. An electron is there, electrons move in the shell. Neutrons and protons in the center of the nucleus, and electrons are in the shells, K shell, M shell, N shell. And it is the attraction of and the protons attract the electron. They pull it towards themselves. And also the nuclear charge. The stronger the nuclear charge, stronger will be the pull, and smaller will be the atomic radii. You will see that. Atomic radii and nuclear charge, how they are related across a period and down a group. These trends you will see. So, and how will we define electron affinity? It is defined as the amount of energy released that is required. Which one? Ionization potential. Keyword that was required, and here the amount of energy released when an atom in the gaseous state accepts an electron to form an ion. To form an ion means here you can give this as X plus it will accept an electron to form an ion. It will form an ion. It will form an ion after accepting it. It will form an ion after accepting it. So say, and this is acceptance. This part you see, and you see this part, how they are different. Here it is released, it is required, and here see what is happening there. Just they are inverse, they are very much related to each other. Okay, see the definition which I told you, and you write it what I have told you. Here what will be formed here? Here an anion will be formed. Here an anion is formed, because the definition says that the amount of energy released when an atom in the gaseous states accepts an electron to form an anion, energy is released. The keyword here is energy released. Here the keyword is energy required and released. Okay, and both of them are having their own trends in a period. So atomic size told you, ionization potential told you, periodicity. Third told you electron affinity. Fourth one, and a very important one, is another one, which you will see and you have to study. That is electronegativity. Electronegativity. Say I draw to just a diagrammatic representation. This is one atom, electronic representation, and this is two elements. This is one electron here. One electron of this one is here. I drew this with a green pen. And I draw something here. One electron I draw here. So this is the shared pair of electron between these two shells. This electron is the common one. It is the common electron which is being shared. Okay, by the other two elements here. Say for example you have to form a compound like hydrogen. The lesson is there in your next part. Electrovalent bonding, covalent bonding, different types of bonding in chemistry. Another interesting lesson. So here I was talking about electronegativity. How do we define that? In terms of electron loss or gain, this will not come, but it will come as the tendency of an atom to attract the electrons to itself when it is combined in a compound. So how much this electron is getting attracted by both of them, electronegativity. One element to form a compound like HCl. And more you will study in the next lesson of your course. This is another trend which you will study across a period and in a group. Okay. Now the next trend which you will study will be metallic and non-metallic character. Okay, metallic and non-metallic character. Now, what is the metallic and non-metallic character? Metallic, you have read in your junior classes. Metals are those, their physical properties like they are ductile, they are sonorous, they are malleable. Non-metals are not malleable, non-ductile. They are the physical properties. But when you wanted to study about their chemical properties, you had compared, you went for like magnesium and sulfur. If you recollect, magnesium burns in air with a white dazzling light. It produces magnesium oxide. So the magnesium oxide, when dissolved in water, produces magnesium hydroxide, MgOH twice, which is basic in nature. If you recollect, sulfur, comparison of properties I am just telling, sulfur plus oxygen, sulfur dioxide. Sulfur dioxide in water, sulfurous acid, that example of that gas jar and deflagrating spoon. And sulfur dioxide is acidic in nature when you bring the litmus paper and all. But here how will you differentiate between a metal and a non-metal? How will you? Metals are those which lose electron. Remember, they form cations, they are electropositive. And non-metals are those which gain electrons, they form anions, they are electronegative. Best definition. And the metals have a large atomic radii. And non-metals don't have a large atomic radii. And all this you will study in a period and in a group. So till now I told you the evolution of periodic table. I told you about what is the periodic table given by Mosley. Then I told you what is periodicity, and periodicity in terms of what you are going to study in terms of atomic radii. or atomic size, then ionization potential, then electron affinity, then electronegativity, then metallic nature and non-metallic nature.